In this video, we are going to do example 1a and b, which are looking at indeterminate forms of type 0 over 0. When I say indeterminate, what I mean is we don't know the answer. There's work to be done. All right, so if you try to evaluate a limit through direct substitution, which is always a great first start, because what if the function is continuous at that point? Then great, evaluate through direct substitution. But if you try that and then the numerator and the denominator are both 0, then we have an indeterminate form of type 0 over 0. So in example 1a and b, we're going to be verifying that we have an indeterminate form of type 0 over 0, and then we're going to evaluate the limit graphically. Later, after we learn L'Hopital's rule, we'll be able to verify this answer analytically. Okay, so remember what these questions always are. As whatever's happening down here, in this case as x goes to 0, what's happening to this function? Y is equal to e to the 2x minus 1 all over sine x. That's this function right here, graphed. Right, and maybe because it's been a while since we've evaluated limits, I think I'm going to keep writing the question. Q for question. As x goes to 0, this y equals e to the 2x minus 1 over sine x. Where does it go? Right? Let's verify that we have an indeterminate form of type 0 over 0. If I put in a 0 for x, we get e to the 2 times 0 minus 1 all over sine of 0. So we get e to the 0 minus 1 all over sine of 0, which is 0, and e to the 0 is 1, so we have 1 minus 1 in the numerator. Over 0, we have a 0 over 0 indeterminate form. We don't know anything here. Okay? Now, if we were just given this question, or this question right here, the only strategy we would have is to go ahead and graph it. And then we'd say, oh, x values near 0 map to, are sent to y values near 2. Oops, wanted a highlighter there. 2, my answer is 2. But we don't have an analytic way to do it yet, but we will with L'Hopital's rule. Okay? So here's our answer. Maybe we'll just practice writing the limit notation again. Equals 2. 2. All right, let's do another one. So here the question is, as x gets big and positive, as x approaches positive infinity, what does this function, y equals e to the 1 over x minus 1 all over 1 over x, where does it go? Question. Where's that going? Where are those y values going? And the graph that we have here is, in fact, that blue function. This is y is. Okay, so if we tried direct substitution, what do we get here? E to the 1 over x minus 1 all over 1 over x if x gets big and positive, 1 over x, right? 1 over huge is on its way to 0. In fact, any number over huge is on its way to 0. E to the 0 minus 1 over 0, a lot like the one that we had before, 1 minus 1 over 0. We have an indeterminate form of 0 over 0. Okay, so we don't have the tools to evaluate this limit analytically yet. So what we would then do is graph it, and then we would answer our question graphically. And here I can see that as x is getting big and positive, the y values are getting really, really, really close to 1. Right? These y values are getting really, really, really close to 1. Answer 1. All right. So that concludes this video.